Okay, in this video we're going to be talking about parallel lines. So just to start with, see if you can remember from last lesson what Euclid's fifth axiom was and write it in the box in front of you, and see if you can brainstorm any ideas of where you see parallel lines in real life. So stop the video now and try and fill in those answers. Okay, so hopefully you remember that Euclid's fifth axiom was a bit wordy, but what it basically said was that if you have a line and a point that isn't on the line, there's only one line that goes through that point that doesn't meet the other line. So basically, Euclid's fifth axiom is just talking about parallel lines and how they never meet. Okay, so they never intersect. Okay, so parallel lines never intersect. And if we have sort of a pair of parallel lines, like we see in this diagram, those blue lines there, we normally mark parallel lines in with arrows that look like that. If we have parallel lines and a line that cuts it, that line is called a transversal. Okay? Now we're going to talk about sets of angles or special angles in parallel lines. So the first set of angles that you need to know are called corresponding angles, and corresponding angles are equal to each other. And in this diagram we have four sets of corresponding angles. So I'm just going to label every angle here so you can hopefully see it. That's A, we'll call that B, C, D, E, F, G, and H, okay? And in this diagram here, angle A and angle F are corresponding angles. They're equal to each other. And the way I like to kind of remember corresponding angles is if you draw, if you kind of trace the transversal in those two parallel lines, you can see sort of the letter F. And if you see that angle there and that angle there, they're sort of on top of those, the bars of the F letter, okay? So angle A and angle F are corresponding. In the same sense, angle B and angle E are also corresponding. So E and B are also corresponding. See if you can find two other pairs of corresponding angles. Okay, so the two other pairs are C and G are corresponding. And also D and H are corresponding. Okay, so there's our four pairs of corresponding angles in this diagram. The second type of angle you need to know are alternate angles. So I'm going to label the angles in the same way: A, B, C, D, E, F, G, and H. And alternate angles are easy to remember because they make a sort of Z shape with our parallel line and transversal. So if you can see, I have a bit of a backwards Z here, okay? But the two angles in the sort of the corner of the Z, this angle and this angle, those are alternate angles. So E and D are alternate angles and they are equal to each other. So alternate angles are equal. So the value of E and the value of D would be the same, okay? And in the same way, if we drew a Z kind of going the opposite way, so I'll do it in the blue there. So if we see that kind of Z shape, then we have another pair of alternate angles, so that would be C and F. So C and F are another pair of alternate angles in this diagram. And the last pair of angles we're going to look at are called co-interior angles, and co-interior angles actually are not equal this time. They add to 180 degrees. Okay, and the way you can see co-interior angles is by drawing a sort of C shape. Okay, and so the angles inside this C shape, so if I call that angle A and angle B, they would equal 180 degrees when you add them together. So A plus B equals 180 degrees. Or if I drew a backward C, so if I drew it sort of going that way, and I said that was angle C and D this time, C plus D would equal 180 degrees. Okay, so three types of angles that we need to know. Co-interior angles, corresponding angles, and alternate angles. And remember, we also learned some other angles in our last video, the vertically opposite angles, supplementary and complementary angles. So we need to think of all of these when we solve problems to do with angles. So let's look at an example here. So we've got a diagram here, and on all your questions, the parallel lines will be marked sort of with an arrow there. So those two lines are parallel to each other. In this diagram, the second example, we've got a parallelogram. So a parallelogram has two parallel sides. So the top and the bottom would be parallel to each other, and then the two sides would be parallel to each other. So that's how we would mark it on a diagram. Okay, let's take a look at the first example. So I've got angle A and B and C that I need to work out. So angle A here, hopefully you can see, is corresponding to that 120 degree angle. So A has to be 120 degrees, and the reason we know that is because we have corresponding angles. So it's always important to write down a reason why you've worked out that angle being what it is. Now we've got angle C here, which is vertically opposite to angle A. So C and A are equal to each other, so C is also 120 degrees because we have vertically opposite angles. And that was from our video yesterday. Opposite angles. Okay, and our last one here is B, and hopefully you'll notice that B is also 120 degrees. And that's because it is vertically opposite to that angle we got there, which we were given in the problem. So that's 120 degrees, and we know that because it's vertically opposite. Okay, let's try a second example. So in this case, we need to work out A and B. So here's A and here's B. And we've got this angle here, which is 72 degrees. So there's a couple ways you can look at it. What strikes me right away is we've got co-interior angles here. So do you see how that C shape is made? So that we know A plus 72 has to equal 180 degrees because we have co-interior angles. Okay, so therefore to work out A, we would subtract 72 from 180. So A would be 108 degrees. Okay, and similarly, B is actually a co-interior angle to that as well. So if I draw another, you can see a sort of, even though it's upside down, we still have a C shape there. So B plus 72 degrees must also equal 180 degrees. So B must be 108 degrees as well. And we're going to learn a bit later, when you have a parallelogram, the two angles sort of diagonal to each other are equal, and you can kind of see that in this diagram, that A and B are going to be the same, 108 degrees, and then the other two angles, this one here and this one, would have to be 72 degrees. Okay, so that's a property of parallelograms that we're going to learn about as well. Okay, so those are the examples on finding angles. So you have lots of different problems to try to practice this with. Remember to make sure to always give a reason. So corresponding angles, vertically opposite angles, like name the types of angles that you have when you're solving these problems.